In the previous video, we saw that a surface can exert a force parallel to itself. Such a force is called a frictional force. However, there is a lot of information missing in that statement. For example, let's go back to the demos that we did in the previous video. In the first demo, I took the air puck here and gave it a push, and then you could see the air puck got slower. Why did the air puck get slower? It got slower because the tabletop exerted a force parallel to itself in the direction opposite the motion of the air puck. However, there are a lot of other directions parallel to that same surface. Why did this surface exert a force in that particular direction parallel to itself? Or we can look at this other demo from the previous video. So in this other demo, I had the air puck sitting on top of a cart, and I pushed the cart, and as the cart got faster, the air puck got faster. Why did the air puck get faster? It was because the surface of the cart exerted a force parallel to itself, and that pushed the air puck along, and the air puck got faster. However, there are a lot of different directions parallel to the surface of the cart here. Why did the cart exert that force in that particular direction parallel to its own surface? To begin to answer that question, I'm going to repeat the experiments that we saw in the previous video, except this time I'm going to turn on the air puck so that air comes out the bottom of the air puck. And with air coming out the bottom of the air puck will be able to move frictionlessly along whatever surface it's on. So I'm going to start by redoing this demo with the cart here, except this time friction is going to be absent. Okay, I'll do that again. All right. What was different when I did the experiment this time in the absence of friction? When I did the experiment in the absence of friction, you could see that the surface of the table slid out from underneath the air puck. In other words, in the absence of friction, we got a sliding motion between the two objects, which did not occur when friction was present. Now I'm going to repeat the other experiment from the previous video, except again, I'm going to have the air turned on so that no friction will be present. Okay, again. How is this experiment in the absence of friction different from the previous experiment where friction was present? In the absence of friction, we get a continued sliding motion, but in the presence of friction, the sliding motion simply stops. So in both of these experiments, turning off the friction allowed sliding motion to occur, which did not occur in the presence of friction. In this experiment here, the absence of friction allows me to have sliding motion between the tabletop and the air puck. In the presence of friction, there's no sliding motion. They just move together. Right? In this experiment, the absence of friction allows the sliding motion to continue. In the presence of friction, the sliding motion simply stops. So what is friction doing? Friction is opposing sliding motion between two objects with surfaces in contact. So now we have the answer to the question I raised before. Why does friction choose to point in a particular direction parallel to a surface. Friction will point in whatever direction it needs to point in so as to oppose sliding motion between two objects with surfaces in contact. So now we can complete this sentence. Okay. A frictional force acts parallel to the surface exerting it. So the frictional force will be directed so as to oppose sliding motion between objects with surfaces in contact.